Hey, this will give you a quick rundown on how to use the Circuit Builder HTML. It'll run on any browser. First, I'll open my folder. And I see here I've got the Circuit Builder Interactive HTML. I'll click on that. As typical, you'll usually have to come up here for the right side for to open this in a new window. Let's take a look at this. This takes you to a nice website called the Physics Classroom. This is a little bit small to read here, so in the upper left-hand corner, you'll see a little icon here. Go ahead and click on that, and it'll make it a full screen mode. There we go. Now, this circuit builder is pretty straightforward or pretty simple. There are just a couple of components that we can have. The battery is already listed there for you. When we click this icon on the left here, it allows us to add wire, a resistor, a light bulb, or a little meter that measures current. That'll come in handy for some of our measurements. Let's go ahead and we'll add a wire to this. Oh, and a note, the battery is already included in here. And say I want to have a piece of wire, click on there. I can add a wire to there. Say I want to put a resistor. Click on there, I've got a resistor, another piece of wire. So now I want to add a little, a light here. Okay, good. Another light here. Then I'm going to put my ammeter here. Ammeter just measures current, and then back to our wire. Notice as soon as I complete the circuit, you'll probably expect, okay, I start seeing current flowing through here. Okay. A couple items you'll see now is that I have the voltage at each of these points. This must be a 9-volt battery. I still have 9 volts here at the head of the resistor. It drops 3 volts to 6 volts as I go across the resistor here. Okay. I'm still at 6 volts along that piece of wire. I drop another 3 volts from 6 to 3 volts across this light, and I drop another 3 volts down to 0 volts to get back to the battery. Notice the ammeter has no voltage drop in it. In this case, I can see I have 0.3 amps flowing through this. If I have equal voltage drops, each of the resistance of these must be the same. Hey, so how can I vary the resistance or make a change to any of those items? And that's done here on that little slide switch icon. I click on there. You can see right now I have a little spyglass on the battery. Over here it lists the voltage. I could increase that voltage. Let's say I want to make it a little bit higher. I've gone from, whoa, getting pretty bright there. I'm going to back this off just a little bit. See, I've increased this to 19 volts. Again, all of our voltage changes around here. And as I'd expect, if I went higher in voltage, I have more current. The lights are a little bit brighter. Just to note, these lights just indicate really how much current is going through. They're not a real good, predictor of how much power is in there. If I can change the voltage setting, I probably can change the value of other things. Let's go ahead and we'll move over here to the resistor. As soon as I click here, you'll see that little spyglass change on there. And down here, I have the value of the resistor. You can probably guess what will happen if I increase the value of the resistance. Yeah, probably total current will go down because in a series circuit, that what flows through one part will flow through all parts. If it's more resistance, it'll be more difficult for current to flow. And you probably see the lights will get dimmer. Yep, they're getting dimmer. Okay. But something else we'll start seeing now with more resistance is our drop in voltage is not the same across each of the components. Across here and across here. Let's go ahead and we'll take that little spyglass. I'm going to move it over to here to this light. Okay. I can see how the resistance in the light here. I'm going to reduce the resistance in this light. We can see here, now let's just take a quick look. We'll go back over here just to kind of make things look a little cleaner. I see I have 19 volts, a big voltage drop. What am I dropping? 12.7 volts across here. Then I drop another, 4.2 volts here. Okay, but I'm only dropping 2.1 volts across here. Remember, that's going to be a function of the resistance in each of these items. Okay, so something else that we see is that even though the current is the same through this, and this has a greater voltage drop, that would tell us this has more power. The light in the simulation isn't any brighter or dimmer. Next class or so, we'll have a little in-class demonstration, and you may have noticed this as part of your labs as well. Hey, one last feature I want to show you before I let you loose on this is a over here, I click on this icon here, and I can get different meters here if I want to measure the voltage in this circuit. So I want to measure it from this point to this point. I can see I have the minus 2.1 volts. That matches what we have here. Well, let's go ahead and reverse these leads, right? Okay, I have 2.1 volts. If I want to measure across some other points here, 6.3 volts, that agrees very well here. Let's say I want to go through over a couple of these components. There. The voltage drop from 19 to 2.1, we can see is about 16.9 volts. Okay, this works exactly the same way as the meter you would have in class. There. Really not much of a reason to use the amp meter, because you can always use these little in-series detectors as well. Yeah, I think that pretty much does it. Let you loose on this. Remember, you're also going to have to build up a parallel circuit. And maybe just one last thing, if you want to make an element disappear, come over here and I just right, what's it? Oh, do I click on it again? Whoops, let me come over here. I'll come up to here, and I believe I just right-click. Yes, we'll make the particular component disappear. And there it goes. I can back those things off. Okay. Hey, good luck with your simulation. Hey physicists, one last thing I'd like to add to the description of our simulation here is how to make a current measurement with the meter. It'll be a more precise measurement, and so for some of you I'm going to ask that you use the meter instead of using these little drop-in indicators. So I'll come down here, icon of the meter, I'll go ahead and click on that. And as before, we have the voltmeter and the amp meter. Remember, to effectively measure amps, what we have to do is break the circuit and then force the current to go through that meter. Okay, let's take a look at here. If I want to see what the current is, perhaps leaving the battery here, what I'll have to do is break this circuit, go up here, I'll remove that wire here, back down to the meters. I'll put one lead at one end of the break, the other lead on the other end. And I can end up seeing here I have what looks like 1 amp. Current leaves the battery, has to go through the meter, and then continues on the rest of the path. Let's go ahead and check maybe one of these branches. Notice there are 3 parallel branches here. So I'm going to come back over here for a pencil. I'm going to break the circuit here. I am going to go ahead and put a wire back in here. I want to know how much current flows along this first branch. Go back over here to our meters. Remember, I want to have the negative, or the black lead closer to the negative end of the battery, the red closer to the positive, and that way the sign will be what I expect. Okay, so I now am measuring current just down this one branch. I can see it's 0.25 amps, a little more accurate than what I would find on these small block drop-in indicators. So please go ahead and use the amp meter for making your current measurements. Again, the technique is break the circuit and then put the meter in where it will complete the circuit. For example, here we end up having kind of an end here. Current needs to get down to here. The way that's done is with connecting the meter across that jump, forcing the current to go through there. All right, good luck.